This video, we will practice some questions on the topic current and electricity. This chapter is very important for your exam point of view, and it basically has a huge weightage in exams. The following questions are for your practice for the chapter and are in line with the competitive exams. So let's start with the first question. So the first question says, drift speed of electrons when 1.5 amperes of current flows in a copper wire of cross-sectional area 5 millimeters square is actually V. If the electron density of copper is 9 into 10 to the power 28 per meter cube, the value of B at V in mm per second is close to what? Now the charge of the electron has to be what? 1.6 into 10 to the power minus 19 coulombs. So we know that the drift velocity is given by the formula what? I equals to NEAVD. Okay, so this is the formula which we are going to apply in this. Now we have been given the current, that is 1.5 amperes, right? And the cross-sectional area is what? 5 millimeters square. This is 1.5 amperes, this is 5 millimeters square, and the electron density is actually what? 9 into 10 to the power 28 per meter cubes. Okay, so now we will put this into the equation. So if I'm going to put this into the equation, then I know that VD is going to be what? I upon N, E and A, and then I is going to be what? 1.5 upon 9 into 10 to the power 28 into 1.6 into 10 to the power minus 19 into 5 into 10 to the power minus 6. So this is what is going to be the equation. So now when I'm going to solve it, the value of VD is going to be what? 0.02 millimeters per second. So this is going to be the answer. Now, coming to the second question. The second question states what? It states two equal resistances when connected in series to a battery consume electric power of what? 60 watt. So they are connected in what? In series, right? Now, if these resistances are now connected in parallel, that is like this, the combination to the same battery, what is going to be the electric power which is consumed? Okay. So the power consumed when two resistances are in series is what? It's actually nothing but V square by 2R, and we know this, right? And this is what? 60 watt. So basically V square by R is going to be what? So V square by R is going to be what? 120 watt. Now when the two resistances are connected in parallel combination, then the power is given by what? 2V square R. Now I know what is the value of V square R by this. So this is simply going to be 2 into 120. That is nothing but 240 watts. So the answer is going to be 240 watts. So let's move on to the third question. The third question says what? The third question says a current of what? 2 milliampere was passed through an unknown resistor which dissipated a power of what? 4.4 watts. Now dissipated power when an ideal power supply or 11 watt is actually connected across it is going to be what? So the case 1 is that I square R equals to P. Okay, that is what? This is the equation which I am using, right? So if I am going to manipulate the equation, can I write that R equals to P by I square? Of course, we can surely do this, right? So I know the value of P, I know the value of I. If I'm going to put it in this equation, can I write that, okay, this is what I'm dealing with, this is not what I'm dealing with. So R equals to P is going to be what? 4.4 upon I square is going to be 2 into 10 to the power minus 3 whole square. Correct. So this is basically what R is going to be. And then this will be equated to what? 1.1 into 10 to the power 6. Alright, now when I take for case 2, so case 2 is nothing but P equals to V square by R, correct? We know this equation as well. And I know that V is going to be what? 11, whereas R is going to be what? 1.1 into 10 to the power 6. This is basically what I came out with, whereas V was what? 11. Understood? So can I write that P is equals to 11 square upon 1.1 into 10 to the power 6? Of course we can do this. And when I'm going to solve it, then my answer is going to be what? 11 into 10 to the power minus 5 watts. So this is going to be the answer, that is 11 into 10 to the power minus 5 watt. So now let's move on to the next question, that is question number 4. I hope you people have understood till here. So let's move on to this question. This question states what? So now a cell of internal resistance R derives current through an external resistance, that is your R, capital R, okay. The power delivered by the cell to the external resistance will be maximum when? This is the question. Now the power delivered to the resistance is nothing but I square R, we know this, correct? So P is going to be what? E square upon R plus R whole square into R. So this is going to be what? The power, okay. Now for maximum power, I know that the derivative has to be equal to 0. So dP by dR has to be 0 if I want to calculate the maximum power. So basically I need to do what? I need to find the derivative of this equation with respect to R, and then I have to equate it to 0. So when I'm going to do that, the equation that will come out is going to be 2R plus small r, which is equal to 0. And when I'm going to solve it, this is going to be what? That capital R actually equals to small r. Okay. How this came out? It's simple. Minus 2R plus R is going to be R. Correct. Minus 2R plus R is going to be R. But because minus 2 is greater than R, so it's going to be what? Negative of R. The negative of R plus R is going to be 0. And then this equation is going to give me what? That capital R is equals to small r. So that is going to be my answer. Now coming to the final question, let's see what final question has for us. The final question states that a metal wire of resistance 3 is elongated to make a uniform wire of double its previous length. Okay. Now this new wire is actually bent and the ends are joined to make a circle. If 2 points on this circle make an angle of 60 degree, that is at the center, so what is going to be the equivalent resistance between these 2 points? And that is exactly what we need to find out. Okay, so I would say that R equals to 3 ohms. Okay, then R, the formula of R is this, and we all know this. Okay, so I'm just going to write it down and little bit manipulate it. So it's going to be L square by V. And after that, I know that R is nothing. R is actually directly proportional to what? L square. Okay, now I know that the resistance which is given here is what? 12 ohm, and this is basically the new resistance. So if this is the new resistance, then what I am going to actually do is that R1 is actually 2 ohm, R2 is what? 10 ohm. Then what is going to be the required resistance? It's going to be nothing but 10 into 2 upon 10 plus 2. That is nothing but 5 by 3 ohms. And that is the answer. It's simple. I'm going to just revise it again. Basically what I'm saying is that R is nothing but 3. Then we have written this formula, this formula in particular. I have manipulated this to this, and when I manipulated this, I found out that R is nothing but directly proportional to what? L square. Now R equals to 12 ohm, which is the new resistance of the wire, whereas R1 is nothing but 2 ohms and R2 is nothing but 10 ohms. So the required is going to be what? 10 into 2 upon 10 plus 2. That is going to be nothing but 5 upon 3 ohms, which is the answer. So I hope you people have understood all of this, and we have just reached the end. So I hope you people have now, gathered the confidence to solve more and more questions related to this topic. You can now go to EduRev and, just try out all the various tests and questions which are given there to just cross-check whether you have understood properly or whether you have confidence to solve on your own now or not. And if not, then you can actually just see the docs and prepare yourself before attempting those tests. So let's meet next time. Thank you very much.